So table 9.4, we're gonna talk all about the heart. This is a really long section. By definition, a vein means that we're coming back to the heart. So we have our return supply here from the superior vena cava and from the bottom here, the inferior vena cava. Both of those are going to pull into this little pocket here, which is the right atrium. And inside the right atrium, we see the coronary sinus, which we'll talk about that blood flow a little later. But just so you know, that pops in the right atrium. Now, the blood will come from the right atrium through this valve, which we can call the right atrioventricular valve or the tricuspid. And we're gonna go into the right ventricle. Once we pass through the right ventricle, we're gonna go up through the pulmonary valve, which the pulmonary valve is a semilunar valve. You need to have the word pulmonary with it. Semilunar is optional. That's just what type of valve it is, but pulmonary is its name. So make sure you include pulmonary. Once we go through the pulmonary valve, we leave through the pulmonary trunk. And then since we're leaving the heart, we are calling these pulmonary arteries. Even though they're blue, blue just means there's no oxygen. But since we're leaving the heart, we are an artery by definition, and we're gonna go to the lungs to get oxygen. So we're gonna go to pulmonary capillaries. Then we're gonna come back through the pulmonary veins, which yes are red, but we just got our oxygen, so we're calling that pulmonary veins. We're gonna pull into this pocket here, which is the left atrium. The left atrium is then gonna go through the left atrioventricular valve, or called the bicuspid. Once we pass through the bicuspid, so we just came through there, we're coming into the left ventricle. And then do you see kind of hiding back up behind? Right there, the red guy, well, it's white and red, that is gonna be our aortic valve. So from the left ventricle, we go through the aortic valve into the ascending aorta, aortic arch, and descending aorta. So that is the blood flow from start to finish of the heart. I didn't necessarily go in order, but I went in order of flow, which I think is super important to know. Now, later on, it's going to talk about the different types of aorta and things like that. But just on this heart, you see ascending aortic arch, descending aorta. Now, actual heart structures that you see, we have the ligamentum arteriosum, which this heart's not showing it super well. It's this white spot here, but we'll switch over to this other heart. We can see it right here, the connection from the pulmonary circuit to the aortic arch. In a fetus, this is open and flowing. When you're a fetus, you don't get oxygen from your lungs. You get oxygen from your mom over in your placenta. And so we bypass a few things in fetal circulation. So in an adult heart, this ligamentum arteriosum is a nothing. It's just closed off that bypass. The apex of the heart is going to be down here, the point. The base of the heart, kind of in the back, you can see this is the base of the heart before all the things are stacked. So base is on top, apex is on bottom, which kind of sounds weird, but yes, that's true. So apex on bottom, base on top. The coronary sulcus is right sitting behind here. And here's our coronary sinus. The sulcus is an indentation or groove associated with the coronary sinus. Now our interventricular sulcus, we have an anterior and posterior. You can kind of see that groove where these arteries and veins sit in the front and a little bit in the back here. So we have two grooves going on the sulcus, the interventricular sulci. Okay, internal structures. So inter means in between. So interatrial septum, this whole area right here is the septum between the two atriums. So you can kind of see one side to the other. That's just separating the two atrium apart. We also see in here, just to remind you, remember that opening, to the coronary sinus. And one more structure in here, this little circle right there, that is the fossa ovalis. And the fossa ovalis, this was another bypass in fetal circulation. This is open when a fetus is getting oxygen, and so blood will just flow right from the right atrium into the left atrium. You may hear about this kind of gone wrong. When a baby takes its first breath, usually this starts to close off and entirely closes off within the first while of being an infant. But you can hear about babies with holes in their heart. That is when this opening doesn't close properly, and it's a pretty easy surgery, but can have problems if not caught. Anyway, so that's our fossa ovalis. So going down, also in the atrium, I guess I skipped one, sorry. We have in the outer wall, this is called the pectinate muscle, and you can see the little crisscross bars in the atrium there. So our atrium have pectinate muscles. Our ventricles have a different muscle we'll talk about in just a second. I might have missed or not talked about, but in the right and left atrium, we also have these auricles. If you see this little extra flap, the left doesn't show it super well, but the right one does. You can kind of see that little elephant ear coming off. It's just extra space for the blood to sit in. So that auricle just provides a little extra pocket blood can be. We have the interventricular septum, and if you remember, we talked about this also being myocardium. So the structure is interventricular septum. The layer is the myocardium. Then we have chordae tendineae. So each atrioventricular valve has chordae tendineae coming off of the valve. These cords are going to attach onto a thickened muscle. Right here, you can see one right there. These are called papillary muscles. So our ventricles have papillary muscles. Our atrium have pectinate muscles. So don't get confused because they'll sound really similar. So papillary muscles, pectinate muscle. And then our trabeculae carnae, wherever we don't have these enlarged muscles, we can see this better in the ventricular walls, are these crisscrosses called trabeculae carnae. Carnae meaning meat, but these are little crisscrosses found in the heart ventricle. Kind of keeps its structure.